Hello, Brandon Lotta here, performing a quick presentation on the U.S. Power Grid Network Defense. Recent events of cyber incidents have grown serious concerns for the well-being of our nation's security and safety. This is especially concerning with regards to the health of our society in the event of an attack that could cripple the U.S. power grid. There are dangers lurking around every corner. The best way for us to prepare is to develop a keen awareness to threats, as well as policies and procedures that enhance security measures. You must know thine enemy. And I quote from Sun Tzu: Know yourself, know your enemy, and you shall win 100 battles without loss. The concept of the adversary model is to develop an acceptable response based on three important components: assumptions, which speculate the attacker's location, internal or external, their accessibility to the network, and their level of resources. Goals. What are the adversary's goals with the acquired information or access? Their capabilities. What are their capabilities? Are they state-sponsored or non-state actors? The cyber kill chain is a 7-step process, beginning with the reconnaissance, where you gather information about the target. You then weaponize by developing a payload. You deliver the payload to the target and then exploit vulnerabilities by installing malware. And then you gain command and control as the attacker gains full access to completely manipulate the system. And then finally to act upon the objectives, which is to act to accomplish the goals. There are different types of malware, such as botnet, remote access Trojan, Cryptor, and many more. The type of malware used will determine the intruder's course of action, such as stealing proprietary data or destroying files or equipment. According to the U.S. Department of Energy's Energy Information Administration, in 2017, the U.S. used approximately 97.7 quadrillion British thermal units of energy consumption. Of the 5 major energy-consuming sectors, electric power is at number 1 for utilization at about 38.1% of the overall consumption for 2017. How is energy distributed to consumers, though? Well, energy is harnessed at the factory, which then transmits the energy in very high voltages to transformers. These initial transformers do what's called a step-up process in order to send them to the power lines that cross the country. From the power lines, the energy is transmitted to another set of transformers who perform a step-down process to be then transmitted directly to the consumers. In the event of a cyber attack against the U.S. power grid, there would not just be economic disaster, but a matter of life and death for many. It would affect businesses and consumers, economies, and create health risks for millions. In order to prevent attackers from crippling our standards of living, we must develop detection and prevention methods to protect our networks, whether in the public sector or private. To do so, we must implement effective defense plans. Let's think about it. Warfare has been occurring since the beginning of times, which means that there has been a long time of developing strategies and tactics. An offensive line is only as effective as its defensive stronghold. For example, the use of the star fort became an excellent defense mechanism in the mid-15th century Italy in response to the invasion of the French. These structures, which were angular, proved more challenging for an invasion than their round predecessors. A modern defense in-depth plan based on the United States Computer Emergency Readiness Team is comprised of 4 layers. 1. The operational layer. 2. The host layer. 3. The network layer. Finally, the security risk layer. Each layer has its strengths and weaknesses. The important thing to remember is that when one is compromised, the rest may serve the purpose of compensation for the loss. However, understanding vulnerabilities is important. Understanding the vulnerabilities is important for planning and execution. For example, the operational layer is vulnerable to human error, which many firms agree that this is the leading cause for failure. And the host layer is vulnerable if the endpoints are not adequately up to date on software, user authenticity, and the integration of intrusion detection and prevention systems. Better yet, a lack of technology is a major vulnerability. The concept of information assurance is to integrate three major components for effectivity. 1. People who are adequately trained and taken care of. Technology, which is up to date and in excellent condition. Finally, operational security, which are the policies and procedures in place. An important method for transmitting information is the use of cryptography. And cryptography is the art of writing and or solving concealed codes and has been around for millennia. Tactic projects protects information being transmitted from adversaries who mean to intercept and exploit the data. This is done by encrypting messages and authentication protocols. It is good to note a great technology that is growing in popularity, and that is blockchain. These distributed ledgers offer a more secure environment for record keeping, authentication, and verification, as well as operations usages, and so much more. This technology is even being integrated into cybersecurity. The goal of protection is achieved through mission assurance. Per the Department of Defense's mission assurance construct, it is developed into a four-process architecture: identification, assessment, risk management, and monitoring and reporting. The National Institute of Standards and Technology defines the industrial control system as an information system that controls various industrial processes, including, but not limited to, industries in manufacturing, production, and distribution. A recent draft published by the National Institute of Standards and Technology issued a guide for the Industrial Internet of Things that focused on 5 areas of interest. 1. Information exchange between facilities and distributed energy resources systems. 2. The policies, processes, and security technologies for trusted device identification and communication amid devices. 3. The malware detection and prevention. 4. Ensuring data integrity. And finally, data-driven cybersecurity analytics. Some of the network defense technologies include firewalls, intrusion detection and prevention systems, and security information event management devices. Some commonly used firewalls include proxy firewalls, stateful inspection firewalls, unified threat management firewalls, next generation firewalls, and threat-focused next generation firewalls. Intrusion detection systems serve the primary purpose of monitoring all events on a computer or network coming in and going out. They detect possible intrusions and report them to administrators for response. Intrusion prevention systems respond to the reports conducted by the detection sensors. Security information and event management devices are used for real-time reporting of events, while integrating the use of long-term analysis of security events. These tools are deployed alongside other defense technologies such as firewalls, network authentication services, and intrusion defense and prevention systems. Network operations are the policies, procedures, and protocols implemented for operational needs. It is imperative that our network are protected against cyber threats. If we are not diligent, the next attack could be against the U.S. power grid, which will bring destruction and chaos to the country. Therefore, let's take the steps to create a safe, conducive environment for everyone. Thank you.